So this is what I want to try and cover in this lecture. I want to go back to design patterns and look at one pattern that I haven't mentioned at all so far, mainly because it's not really concerned with the area of reusability. It's more concerned with dealing with a specific problem that can arise, not just in web apps, but in apps in general, where you've got data that you want to share across multiple components or units within your application. How can we do that in an efficient way from a programming perspective? And one answer is to implement it using this provider pattern. The second thing is data fetching and caching. Now, it turns out that our Movies app so far is actually extremely inefficient in terms of its communication with the TMDB API. It's actually making far too many API calls than it needs to. So I can show you that happening, and then we will have a solution to it, which is to implement what's called caching within the browser. And there's a really nice third-party library called React Query that does that for us. The last thing then is there's one sample left in the set of navigation samples that I've given you, and it deals with how you can make routes within your application private or protected or authenticated. I've left it up to now because it turns out that that particular sample uses the provider pattern. So it's dependent on that. And as it turns out, the middle topic there, data fetching and caching, that also uses the provider pattern as part of its overall solution. Now there's two parts in the title of this slide. One is the provider pattern. So we know that patterns are all about generic solutions to commonly reoccurring problems. So there's one commonly reoccurring problem that this provider pattern will deal with. The other title then there is React Context. So a context is a construct that React provides to us to allow us to implement the pattern essentially. So it's specific to the particular problem that the provider pattern deals with. And so what is that problem, or when would we use this provider pattern? In the general case, you use it if you've got a unit within your overall application architecture that has some state or data that it would like to share with lots of other units within the application. Now, in a React context, that means we've got a stateful component and it wants to share some of or all of that state with lots of other components in the architecture. Now, the traditional way of doing that is that stateful component would be very high up in the component hierarchy, and it would pass the data or share the data via props. But that can result in what we now refer to as prop drilling, which I mentioned in the previous lecture. So we don't like this prop drilling approach. We'd like a better solution to it, and the solution will be to implement this particular pattern. So it's about sharing global or global data, yeah, let's say sharing global data across multiple components in our architecture. Here's a kind of a visualization of it, which I found on the web with, I don't like the emojis in it, but there you go. And so what we're trying to get across here is here's a component that's stateful, and it wants to make part of that state available to part of the state values available, let's say, to this component down here and to these two here. Now, the only way we know how to do that right now is it needs to pass props right down through various intermediaries in order to get the data down to the components that actually need it. And that's what we call prop drilling. This is prop drilling going on here, which we don't like. And similarly over here. So that's the use case for this pattern in a React situation. The how then as to what are the sort of elements of this pattern, if you like, and I'll describe them in general, and then we look at the actual implementation, which can be slightly tricky initially to get your head around. But At a very general level, so we've got a component that has some state data. So it's an ordinary stateful component, and it wants to share that data with lots of others. So the component that's managing the state data, we refer to it as the provider component in the context of this pattern, but it's just an ordinary stateful component. So we would know how to declare our provider component from what we know so far. Step 2 then is where we start introducing this context construct, which is specific to React. So we declare it some way, it's just a one-liner, and we need to associate that context construct with the provider component. We need to see how to do that programmatically. Step 3 then is we actually sort of add some of the state data to the context. We sort of put the data into the context. Step 4, we use composition between this provider component and what we call consumers. Consumers are those other components that need to access the data. But essentially what we will do is we will compose the provider component with the entire rest of the app, so that any other component that needs to access the context can. There's no gain from just composing the provider with specific consumers. You're better off just composing it with the rest of your component hierarchy, as we'll see. And once you've done 4, then the particular consumer components, those that are interested in values inside the context, there's a hook available to us to access the values inside the context. So that's the kind of generic sequence of steps that we need to implement. So the context is really, this context construct is central to how we implement the provider pattern in React. And I'm saying there that it enables a component to share some of its data with anybody else that's interested, any subordinates. They do have to be subordinates though, that are interested in the particular data. The provider component, it manages the context. In other words, it decides what goes into the context and whether those values can be changed or not. And number 3, then the consumers then just access the values inside the context. And as we'll see, the context can be changed. The values inside the context can be changed by the consumers, provided the provider provides functions that allow them to do that, of course. So the provider is always in control. Here's my kind of visualization of the context construct. So it's that orange box on the top left. So the provider in this case, again, is, let's assume it's this guy here. So it's responsible for initializing the contents of this construct. And we associate the context with the provider. But once that's done, and once we have composed this component with the rest of the app, then essentially any component can access the context directly to get values from it. But that's just a visualization. Here are the kind of nuts and bolts then of how you achieve it. Some of them are straightforward, some of them are a little bit tricky. So number 1, we've got to declare our provider component. And here it is here. It's just an ordinary component. It has some state, let's say. It may be using the use effect, which it may not, but it's definitely using use state to initialize the particular state data. Now, this line here is, it's outside the provider component. This is how we declare a context construct. So it's a one-liner, but all this line is doing is it's declaring an empty context. Now, in order to associate the context with the provider, this is how we do it here. This is where it slightly jars with the kind of flow of React. So essentially, my provider component its JSX includes a reference to the context construct that you've created up here. And we refer to it using ordinary JSX syntax. So the context name, that provider, that has the effect of linking my empty context with my provider component. And this, so we need to initialize a prop for this context.provider. Now this prop is really important. This prop here is how we actually fill up the context with its content. So the values prop has to be assigned an object, key value pairs, and these key value pairs is essentially the content, the data content of my context, which the provider is making available to any other component that's interested in it. So presumably the consumers will refer to a particular key within the context in order to get the value associated with it. And this value will be more than likely associated with some state variable that the provider manages. Notice as well here, I'm referring to props.children. So I expect to be composing my provider with something. But for now anyway, declare your context, empty context, declare your provider component, which is going to be managing the state data that's going to be globally shared. Link the context with the provider by using this approach here, and initialize the contents of the context using this special values object declaration. A little extra thing down here at the very bottom. Turns out, right, I've been talking about the provider pattern as a way of sharing global data across multiple components, but in fact, the context may contain behavior that you want to share across multiple components. And by behavior, we simply mean functions. So the provider component may have functions declared inside, and we want to share those functions or make those functions available to consumer components so that they can invoke the functions. In the majority of cases, the functions would be concerned with changing the values inside the context, updating the context, in other words, i.e. changing our state variables. And as always, if the state variable changes, then this component is going to re-render and all of its subordinates are going to re-render. In terms of composing this context provider component, we tend to do that in the component that has all of our routing configuration. So the composition is very high up in the component hierarchy. And as you can see here, this component is the one that has my main routing configuration. It's also the component that I attach to the DOM. But here's where my composition between my context provider component is happening. Okay, so all inside here would be all of your normal routing configuration, which of course is referring to all of your pages. And so that means any of your pages will now potentially be able to access the context that is provided by my context provider component. And indeed, any components within those pages have the potential to access the context construct within my context provider. That's just the nature of composition. Next is the actual consumer. This is the component that needs to access the values inside the context. And in general, what the consumer or a consumer needs to do is it needs to use the special hook called the use context hook. and its argument is just a reference to the context construct that you created. So this here is referring to this here. Okay, notice how I export the context construct. So my consumer now, essentially, it now has a reference here to the context construct. Now, essentially what that means is that this reference here, I should have a const there. This is an ordinary constant variable. And what it is actually referring to is the values object that you created here. So when we say a consumer has a reference to a context, what it really has is a reference to the values object that is exposed or contained within that context construct. And so if that's the case, if that now is referring to the values object, then, you know, by just using something dot key, where key is one of the keys inside my values object, that expression is now going to evaluate to a particular value inside in the context. In other words, the data that the shared data that the provider component is making available to us. So here's some excerpts from an actual consumer. Here it's using, notice here how I'm importing the context construct. Okay, again, I go back to it. This now, this path here would be referring to the file, would be referring to this file here. And in particular, we're referring to this export from that file. Sorry now for jumping around these slides. And as well, I'm importing the actual hook. Here I'm using the hook and referring to my context. I'm labeling the point, I know, but it's not the provider component that you're referring to here. It's the actual context construct that you're referring to. And here then is where I would go context dot some key in order to get at some entry within the context construct. So we use this pattern in our movies app, and in particular, we use it to make the favorites available to any other component that needs to access it. As you will remember, there are two pages that need to know about the favorite movies, the home page and the favorites page. So we'll use this provider pattern to share that data between those two pages. So we're going to have a separate new component, which is going to be our provider component. And it's the one that's going to have the context, declare the context and sharing the context, etc., etc. So you see that in the lab. In many cases, you know, you may have a number of different aspects of data that you want to share with across your component hierarchy, but the data may be slightly unrelated to each other. So what I'm trying to get at is, rather than having one context that is responsible for sharing all different types of global data across your app, it would be better to have multiple contexts, so that each context is concerned with a specific aspect of global data. And of course, the reason we do this is to achieve better separation of concerns, which is, you know, an objective we like. So separation of concerns applies to this provider pattern as well. And so if you have multiple providers, then, you know, how you link them all together would be like this. So we know how to declare them. This is how we actually compose them with the rest of the app. So you just simply nest them inside each other. Usually it doesn't matter the order in which you're nesting them, usually. It may in some cases, but so this is how you would actually compose your In my case, I've got two different contexts and I'm composing them with the rest of the app. We don't do it, we kind of do it indirectly in the Movies app. We don't do it directly. We only have one particular context, which I'm calling the move, which I think I call the Movies context. But there are other contexts being used as well, as we'll see in a while. Now, this slide I'm only including just for completeness. It doesn't really apply to us, but there are certain cases when it's not a good idea to use the provider pattern. Just because you've got data that maybe more than one component needs to know about it, you shouldn't straight away think, let's implement the provider pattern. Number one, I'm saying here is don't use the provider pattern if by not using it, you would actually only have fairly shallow prop drilling. By shallow prop drilling, I mean if you're only passing a prop down one level or maybe two levels, then that's better to use prop drilling rather than to use the provider pattern to avoid that that shallow prop drilling, as I'm calling it. Because as it turns out, the provider pattern can be inefficient in some cases, or in other words, the context can be an efficient way of dealing with global in some cases, and in particular in this case when you've got shallow prop drilling. Now I kind of break that rule because I think in the Movies app, where I'm passing the favorites around the place, they are actually only being passed maybe down one or two levels. Well, certainly two levels, not one level. Two levels or maybe three levels. I'm not exactly sure now in my head in terms of the hierarchy. So strictly speaking, maybe using the context wouldn't have been a good idea, but I wanted to include it anyway in the app so that you have seen an example of it. The second case when you wouldn't use the provider pattern, I suppose it's fairly obvious really, but you might find yourself in this situation where you've got a component that is stateful and really the proper place to manage that state is within the component itself. Don't put it into a context because you actually realize maybe that it's not being shared or being consumed by any other component. Initially, it might have been, but then after some refactoring, maybe there are no longer any consumers that need to know about that state, and you're better off in that situation then to get rid of your provider pattern implementation. The third case, again, would only arise in a production environment, but if the objects within your context construct are very large in terms of their nesting, then that it may lead to poor performance of your React app in terms of responsiveness. Again, I'm only just documenting this for the sake of completeness. It won't arise in our case. And the advice is that if you do have large objects, this again would be in a production environment, if you do have large objects within your context, then you should do some performance testing to ensure that it's not impacting on the performance of your React app. And if it is, then revert back to come up with some other solution other than using context, which really means go back to using prop drilling because that is actually more performant. So it's not a silver bullet, this pattern for global state sharing. It's just an option that's available to you. Now, the next section is data fetching and caching. Data fetching relates to our communication with the web API. And caching is a technique that we're going to use to improve the performance of our app in relation to that API communication. This is really kind of a subset of a larger topic, which is called state management. State is data. Obviously, our single page apps manage data that they receive from the API, and also maybe data that's local within the browser. Either way, it's state or data that needs to be managed within your code base. And how do we do that in how do we program that, I guess? I first of all want to define what I mean by state, because there are two aspects to it. So it turns out that a single page app, so I'm talking about single page apps in general now, not React specifically, has two types of state or data that it needs to manage internally. One is data that we refer to as client state, or it's also often called just app state. And examples of it would be if you've got an app, let's say, that has a drop-down menu, and on selecting one entry in the drop-down menu, that causes your app to change its UI. So in the case of the movies app, the genre and drop-down list would be an example of that. When the user selects a genre, we need to store which genre they have selected somewhere within our code base, within a component, as it turns out. Another example of client state or app state would be if our app allowed the user to change the UI's theme. Let's say it had a dark theme and a light theme that the user could just change within the browser itself. Then we would need to store somewhere which theme the user had picked, so that or as to what components could use that to decide how it should render its UI. Any text box in any form, for example, would be another example of client state. Maybe recording what user is currently logged into the browser. That would also be classified as client state. And the characteristics of client state are as follows. It's owned by the client. So if you had multiple users running our Movies app in their own browser, then each instance of the Movies app would have its own sort of local client state. In other words, for example, one user might have selected one option on the genre drop-down list. Another user on a different browser would have selected a different genre. So client state data is owned by the client, we say. It's not shared by the clients, obviously. And it's not really persisted anywhere, long-term anyway, between sessions. Typically, we don't persist this data between sessions. Let's assume now that we're not doing cross-session kind of storage, this idea of where you log in once and then you come back to the browser later on and you go to the same website and you're still logged in. Let's assuming we're not doing that. So there is no persistence of our client state data, which there typically isn't anyway. Secondly, in terms of accessing our client state, we access it synchronously because it's local to the browser. So that would make sense. So it's quick response when we try to access client state. And in the case of React, we would store client state using the useState hook. Now, the last thing here I'm talking about, where exactly within our code base should we manage client state? One option would be that each component would manage its own part of client state. That would be good from a separation of concerns point of view. If some of that client state had to be shared across multiple or shared with multiple components, then as we've just seen, we could use a context to store that particular aspect of client state in. So there are two reasonable options for client state data. The second type of state that a single page app needs to manage is what we're calling server state. And server state really is, you might remember at the very beginning I said that the React framework didn't follow the MVC pattern, and in particular it didn't concern itself with the M part of MVC model. Well, server state is really referring to the M part of MVC. So for the case of our Movies app, the list of movies that we get from the Discovery Web API, that would be an example of server state. The movie details would be another example. In our Filtered Friends app, the list of friends would be an example of server state. So essentially any data we get from the backend, but we're storing, when we retrieve that data from the Web API, we need to store it somewhere within our single page app code base. so that it's available to the rest of the components while the app is up and running in the browser. The characteristics of server state is very different from that of client state. Number one, it's actually persisted remotely. In other words, it's persisted back at the web API. It is shared by all of the single page app instances that are running at any particular point in time. So it's got shared ownership. The second line, I'm saying that it's accessed asynchronously, which characterizes it differently from client state. And of course, once you talk about asynchronous accessing of anything, of data, in particular in this case, then that impacts on the user's experience because there's a latency component brought into question. Next, I'm saying that it can change without the client's knowledge. So if you've got two users using a particular single page app, and it's talking to a backend, and the single page app allows the user to change some particular piece of server state back at the web API side, then one user might make a change to it, which means the other user running the app in their browser potentially is looking at out of date data, which is not a good thing, obviously. In terms of how we implement server state in a React app, we now know that we use a combination of the useState and useEffect hooks to do that for us. Now, sticking with server state, the question of where within our component hierarchy do we manage server state data? And I'm providing three options here, all of which we know about, but as it turns out, none of which are ideal. One option is that each component within your hierarchy is responsible for managing the particular part of web API data that it requires. So that component would make the HTTP request for the data using the useEffect hook, and it would store it in a state variable within the component itself. That's a nice solution from a separation of concerns point of view, in that each component essentially kind of manages its own part of server state data. What's not good about that approach, though, is that every time that component is remounted, and we know that mounting and remounting can happen many times while an app is running within a browser session, every single time the component is actually going to re-request that data from the API. Remounting, remember now that every time a component mounts or remounts, the useEffect hook does run. And so we can't stop that from happening. So it's going to be re-requesting the same data every time it remounts, and clearly that's not a good idea from a performance point of view. So we've got some good points, but we've got some bad points as well, if we decide that each component manages its own particular part of server state. The second option is to, use the context construct that we were talking about earlier on, put it into some sort of high-level provider component and let it manage the state, probably most or all of the state, or you could have a couple of contexts, but either way, these contexts are going to be linked with provider components that are very high up in the component hierarchy. And because they're very high up, okay, they're mounted once and they're never remounted typically. So they only request the data once, which is good. So there's no unnecessary refetching of data. The problem, though, is that these provider components are always mounted during application startup. So they are going to be requesting data which the user doesn't really require yet. In other words, the user hasn't navigated to a particular page that needs that data. So it's doing all of the data fetching at the start during the app load time, but the load time now is going to be slow because of that. And arguably as well, we've got poor separation of concerns, because now we've got the components that need the data, that render it, are separate from the components that actually acquire the data. The providers are acquiring the data, but it's other components that are the consumers, as we call them, that are using the data. And that's a poor separation of concerns for state data, for server state data. It's okay for client state data, but certainly not for server state data, because essentially we can't, if we want to take those particular components and use them in different application, then we've got to bring the context provider components that are requiring the data, we've got to bring that with them in the other applications. So poor separation of concerns. A third option, so essentially what we're saying here is to use the context construct within React. A third option is to use a third-party library to take care of managing server state data. The most, and there are lots of these out there. The most popular one is a third-party library called Redux. So I would say that Redux is a state management library, and when we talk about state there, we're really talking about server state management library, third-party library that you can use with your React framework. And that by far and away, that is the most common combination that you will see out in the industry at the moment. If you read around blogs at all, if you do a Google on React Redux, you'll get loads of hits of showing you how to use these two frameworks together. But essentially, this third option is really the same as option 2 in the sense of it has the same advantages and disadvantages as option 2. So we'd like to take, at the bottom I'm saying, we'd like to take the good parts of 1 and 2 and drop the bad parts if that was possible. So we'd like to have good separation of concerns, but not have unnecessary refetching of data. That's our ideal solution. Good separation of concerns in the sense that each component will be responsible for requesting its own web API data. But just because that component remounts lots of times, it won't be re-requesting that same data every time it remounts. That's what we'd like to have ideally. As usual, I've got an app to demonstrate what I'm going to be talking about here. So it's a variation on the filtered friends, and I've got my filtered movies. So on the left is my home page, and I'm using TMDB obviously in the background. So my home page makes a request to the discovery endpoint, and it lists all the movies. And I can do my filtering, although that's not really of any interest to us. These are clickable, and if I click on them, then I'm taken to the page on the right. Now, because in this app, I'm not really concerned with UI, the look of the UI, I'm really concerned with the communication with the backend. So all I'm doing on the second page, the page on the right, the movie details page, is I'm just displaying the contents of the movies object as a JSON object. That'll suffice. Both of these pages make their own HTTP requests, so that's good from a separation of concerns point of view. Here's the downside though. So on the right, I've opened up my developer tools, and I've specifically clicked on the network tab within developer tools. That will show me all the network communication that's going on behind the scenes as my app is running in the browser. And so what we see happening down here is when I loaded the app into the browser first, then the home page rendered, and my home page made a request to TMDB to get a list of all of the Discover movies. And that's essentially what you're seeing here. This is the API request, the HTTP request to the discovery endpoint. Then I clicked on, let's assume it's the first movie. I clicked on the first movie. So the movie details page loaded. And that page made a request to TMDB to get the details of that movie. That's fine so far. Then I went back to the home page, and lo and behold, the home page made another request to the discovery endpoint to get all the movies. And this is not necessary. We shouldn't really have had to do that. And it's obviously going to delay my rendering process. Okay, we don't see it to the naked eye, but because our app is very simple, but in a larger, more complex app, you would get a latency impact because of that extra HTTP call. So it's making an unnecessary call here. Then let's supposing I clicked on the exact same movie. So the movie details page now loads, and it goes along and requests the movie details, which it has already requested earlier on. So this is also unnecessary. Back to the home page, and on we go. So loads of unnecessary communication with the backend going on behind the scenes there. And we want to eliminate that, obviously. Now, you'll get the app as an archive with this week's lecture, and it's the usual story. Download it, unzip it, run npm install. So I have the app here. Now, essentially, I just hacked the Filtered Friends app, as you can see. So some of the components are taken directly from the Filtered Friends, but I've just renamed them. Instead of the friend component, I have a movie component. Instead of the filtered friends list, I have the filtered movie list. And they're the exact same as before. But let's just take a second to skip through some of the elements. So these two components, as I said, are essentially the same as what we've seen from the filtered friends. So I don't really need to look at those. You can look at them yourselves. The pages is what we're interested in. We have two pages. Here's the home page, and this is the state variable that's going to be storing my list of movies from the Discovery API. Here's the use effect hook that's making the API call. For no particular reason, I've switched to using async await instead of using the more traditional promises-based communication model. So I'm using async await here. Get movies is just inside in this separate file. There's my get movies. So it's using the fetch function again, but as I said, I'm just using async await, so that's not really significant. And this is the handler for the text box, which we're not really interested in. It's doing the filtering. Here I'm computing my list of filtered movies, which is also not really of any concern. And I'm rendering all of the movies using the filtered movies list, which is the exact same as the filtered friends list. The other page then is the movie details page. The movie details page gets the movie ID from the parameterized URL, so that's really what's going on there. We know that from before. And it makes its own API call to get the movie details, and it stores the movie here. And as I said, from a rendering point of view, I'm just rendering the movies as a JSON object because I'm not concerned with the UI side of it. Let me just run it. Now we'll open up our developer tools because we're interested in seeing what's happening in the network side. So I have the network tab open already. And what I'll actually do is I'm just going to do a manual refresh. So there's my API call to get all of the movies, the discovery. Then let's click on the very first one. Now it's made the API call to the movie endpoint, back to the home page. So made another API call to the discovery API again, discovery endpoint again, click on the same movie. So it's done the API call. So these two API calls here are the exact same. You can tell from the movie ID, and on it goes. So can we eliminate these unnecessary backend communications once we've got the data once? That should be sufficient, because in particular for this movies app, because the data at the backend is not really changing, or certainly it's very infrequently changing. It certainly doesn't change during a particular browser session. It may change from one browser session to the next. In other words, for example, the list of movies may change from one browser to the next, but given the way TMDB updates, it's probably only on a fortnightly or monthly basis. So it's very infrequent either way. So that's the problem. What's the solution? And the solution is to use something called caching. So we need to talk a little bit about caching first, because caching is not specific to single page apps talking to backends. You can also use caching between the backend and the database, but in this case, I'm specifically using it to interrupt the communication between your single page app and the backend. So a cache, anyway, I'm saying is a cache is something that stores the API data locally in the browser. So it does that for us. We don't have to do it within our components, as we'll see. Secondly, I'm saying that what caches are in-memory data stores. So they're a kind of database, if you like, but they're in memory rather than being remote. And they're characterized as being of high performance, low latency, which is really what we want. We don't want the cache to, if it has the data, then it'll return it to us immediately. And so the overall benefit to our app is that we get a more performant app with less latency in it as a result of using a cache. But it's an in-memory data store of your API data, or any data really, but typically web API data, in this case anyway. The benefit is, in this case, it's going to help to reduce the workload on the back end. So like an additional benefit is, if you had hundreds of thousands of instances of our movies app communicating with the back end, then all of them would be hitting the back end with requests. And so that's obviously going to impact on the overall performance. But if each instance of the app has its own local cache of data, then there are potentially going to be less requests arriving at the back end to deal with. So that's an additional benefit. This is my kind of architectural representation of it. So I've got my single page app running in the browser, and the caching technology is also running in the browser. And here's my web API that is remote. So any communication between these two are asynchronous. Any communication between these two are synchronous, because they are co-located essentially. And so in general, how caching works, we're talking about caching in general now. In general, your single page app is going to ask the cache, do you have a particular piece of data? Like, do you have the details of a particular movie? Or do you have the list of discover movies? If it doesn't have it in its data store, it will ask the API for it. The web API comes back with the data. The cache will store the data locally and then pass it on to the single page app. Later on during the same session, if our single page app now asks the caching technology for the same piece of data, then it'll check to see does it have it. It has it. So now it'll actually give it straight back to the single page app. So it's as simple as that, really. So caches, they are key value data stores. That's how they're That's how they structure their data stores. You could call them databases if you like. Keys are obviously unique. Values can be anything you want them to be. So a value can be a JavaScript object or a network of JavaScript objects or a JavaScript array or whatever way you want to mix it up. As long as the data is serializable, then it can be stored as a value. Okay, I'm mentioning it could be, technically the value could be a primitive, but you know, it's in very rare cases it would be a primitive. It's usually some sort of structure, be it array or an object structure. Just some other terms in relation to caching. We talk about cache hits and cache misses. A cache hit occurs when the data that the client is requesting is actually in the cache's data store and it provides it to the client immediately. A cache miss is when the data that's requested by the client is not in the cache's data store and it has to get it from the backend itself. So if I go back to the previous slide, I would say that, well, what we would say is that here a cache hit occurs because the data that was requested was in the cache's own data store and it provided it immediately to the client. Up here, a cache miss occurred because the data that was requested by the client of our cache doesn't exist in the cache's data store, so it has to get that data from the backend. Next thing I'm saying is that caches have a very, usually they have a very simple interface. Usually there's a very limited number of operations that you want to carry out on a cache, that a client wants to carry out on a cache. And they are typically, the client wants to ask the cache for a particular piece of data, which we tend to refer to as a GET request. So in a GET request, the client just specifies the key of the particular data item, and it's up to you, by the way, to decide what are appropriate keys. I have the next slide talks a little bit about keys, but so a GET request would essentially ask the cache, do you have a particular, or give me a particular piece of data? Now behind the scenes, the cache will look in its data store. If it has it, it returns it. If it doesn't, it makes the API call. The API eventually comes back with the data, the cache stores it in its own data store, and then it provides the response back to the client. So technically, I suppose this could be synchronous or asynchronous depending on what the state of the cache's data store is. Another type of operation that a client might want to perform on the cache is to ask the cache to explicitly delete an item from the data store, because the data store in the cache can grow and grow and grow. So it's up to the client to decide, well, the client can actually tell the cache to get rid of certain items if it knows, I suppose, if the client knows that it's not going to be using it in the immediate future. Also, the client can potentially ask the cache to completely wipe its data store. That would be, I suppose, appropriate if the nature of the data in the cache is frequently changing at the back end. Then there's no point in holding on to it in the cache's data store for prolonged periods of time. Now, what a prolonged period of time really depends on the nature of the data. It depends on the frequency with which the data changes. We're not going to get into that, but that would be a consideration, obviously. Also, in general, the entries that go into a cache, they should have what's called a time to live attribute associated with them. And the time to live attribute determines how long the item should reside within the cache. And if an entry within the cache's data store, if its time to live value has expired, what the cache will actually do is remove the item itself. So while up here, the client can explicitly ask the cache to remove an item, the way caches are actually designed, they have a built-in mechanism for removing what we refer to as stale data within the cache. And it's via this time to live. And that's something that you can configure as the developer. Now, to bring this back to our React app context, there is a third-party library called React Query, and it implements this caching idea for us. So it's going to manage essentially any server state data for us. And it's only something I've come across fairly recently, like within the last maybe 6 months or so, and it's only been grown in popularity within the last, let's say, 18 to 24 months. So it's pretty new on the scene, but its popularity has actually rocketed. So it's extremely heavily used within the industry. And it's also an opportunity for you to understand this notion of caching, because as I said at the outset, caching is a technique that we use a lot in any kind of distributed systems architecture. Now, in relation to this React query library, it essentially is a set of hooks. It provides a set of React hooks that we can use. That's how we interface with it. So on the previous slide, I was talking about making GET requests and delete requests and purge requests to our cache. The React query library doesn't provide us necessarily with that kind of interface. It simply provides us with a set of hooks that we can use in order to make what are essentially GET requests, I suppose. So here's one example, and here's the most commonly used hook called the use query hook. And so the way you interpret this is I'm asking my React query caching library to give me a particular piece of data, the data that has a particular key. And so it will look in its cache, as I said, and if it finds it, then it returns it back to me. If it doesn't find it, then it needs to actually make the HTTP request. Now, the React query library, let's bring this in relation to the TMDB or our movies app now. The React query library doesn't know anything about TMDB or how to communicate with TMDB. So the second argument to this hook is going to be a function, and that function is what we implement, and it will contain the code necessary to make the HTTP request to the backend for the particular piece of data. So what this use query hook will do, as I said, is it'll first check to see, does it have this particular key in its cache at the moment? And if it doesn't, it invokes this function, which will make the HTTP call. Eventually that will respond back. When the response comes back, it will then put that entry, that response, into its own cache data store, where the key is going to be this value, and then it'll eventually return it back to us or to the client. Now you can see here, as is typical with hooks, what the hook returns is an object. And the object structure is where we, as the client, as the React client, this is what we work with. We work with these values here. So what do each of these values mean? Because remember now, there are two scenarios here. Either there is a cache hit or there is a cache miss. So the data part of the object is obviously going to contain the data that we're looking for. So that will either be data that is currently in the cache, or it will be data that was eventually returned by the web API and put into the cache and then returned back to us. The error is also an object, and that would be relevant if the HTTP request made by React Query failed. In other words, the web API returned an error response. So this hook is just simply making that error response available to our React code, and it's up to us to decide what we want to do with it. These two things are just Booleans. The isLoading Boolean is what we can use in our React code to decide what we should render while we are waiting for TMDB to respond back with the data. So this is going to be relevant when the React query has to actually communicate with the backend in order to get the data. But what React query will tell us immediately is it will set this value, this Boolean, to true, so that our React component knows that React query is currently communicating or awaiting a response back from the backend. So typically we would have this in some sort of if statement where we would render some sort of waiting for data to the output that to the screen. This is another Boolean, and this really is going to be true or false depending on whether the eventual response that came back from TMDB was an error response or a 200 response. So this is classic kind of hook semantics going on here. The hook returns an object, and it's we use the values within that object then to conditionalize our component code. And we'll see an example of that in a second. What I'm also saying down here is that this hook will actually cause our component to re-render, which, you know, obviously if the hook has to make the API call to TMDB, then that's an asynchronous, and eventually it comes back. And when the response comes back, then we want our component to re-render because we now have the data. So it does in the same way that the use state hook caused a component to re-render, this use query hook does as well. And secondly, essentially, it means that we no longer need to use the use state and use effect hooks in our components to communicate with the backend. We can now use this use query hook internally within the use query hook. It has some variation on the use effect use state hooks buried within it. So let's use this in the sample app that we've been looking at. Now, in the README, I explain the steps that you need to carry out. So it's essentially 2 cut and pastes that you need to do. First of all, in the home page, what we need to do is we need to take out the state management that we're doing ourselves, which is all of this code, and replace it with the use query hook. So it explains here, as I say. So I'm replacing in the home page, I'm replacing the code that I've just cut there, and I'm inserting this instead. And just a quick look at what we've inserted. So here we are using the use query hook. We've decided that I'm going to use that as my key, as in I'm requesting the set of movies from the Discovery API. So that's a sensible key name, I'd suggest. Here's the function that the library should use if it needs to make the HTTP request. That function we've already looked at, but here it is here. So it's making the API call, and it's returning back to me essentially a promise. That's what I'm returning here. And then I'm destructing what it returns back, what the hook returns back. So I'm checking to see if isLoading is true, which means React query has had to make an API call to TMDB and it's waiting for the response to come back. So as a temporary solution, I'm going to render that out onto the screen. The component is eventually the TMDB is going to come back, and the use query is going to put the data into its data store using this as the key, and then it'll trigger a rendering of my component. At this stage, data is now going to be pointing at the set of movies that have been returned from TMDB. Essentially, data is going to be pointing at the object associated with this key in the cache. Well, it's not going to be pointing at it directly. What the use query hook will do is that it will, as we say, deserialize the data that has come back from TMDB and make it available to me. It'll store it in the cache in a serialized form, which is no good to me, really. It's no good to our code. We need it deserialized. So data is effectively going to be pointing at an array of movie objects, essentially. And so on the re-rendering of this component, this is now, his loading is going to be false, so it's going to skip over that. His error, hopefully, is going to be false as well. And I'm just accessing, because remember the data that was returned by TMDB when it makes a request for the set of movies is an object that it returns back. And within that object, there is a key called results. That's really what I'm dereferencing here. So I'm getting at the results, which is my array of movies. And it's back to the same old story. Then I'm filtering my list of movies based on the contents of the text box, etc., etc. So I'll save that change. And let's see the impact on the app. I'm just going to do a manual refresh here. So it's made a call to TMDB for the set of movies, which is right. I go to one of my movies. And now when I go back to the home page, there's no subsequent communication with TMDB for the full set of movies because it already has it in the cache, as is evidenced from this request. Go to another movie. Now I had to make this request because I haven't brought in the React query caching into the movie details page yet. So every time I go on to the movie details page, it is going to make a HTTP request, whether it needs it or not. But when I go back to the home page, okay, so now we can see that caching is working because it's not re-requesting the full set of movies. Now, for this particular usage of the use query hook, my key was simple. It's a static string, and that made sense. But it won't always be a simple static string. So going back to the slides, I'm just talking a little bit here about the query key itself, or the key that you're going to use for a particular entry in the cache. And this, I've literally cut and pasted this from the React query documentation. Essentially, the key can be any type of serializable object or array. So for example, and it arises in the case of our little simple app, when we want to store a particular movie object, let's say in my cache, then I'm actually deciding that my key for that is going to be constructed from this array here. I'm going to prefix the key with this string movie, followed by this simple object, which is going to be serialized. And so the entire key for a movie is going to be a serialized version of this array, where this is going to be variable in general, but I'm just hard coding a movie ID for the sake of illustration. That means that, so when we ask React query, do you have this key in your cache? And if it realizes that it doesn't, it now must go away and use this function to communicate with TMDB. This function presumably needs to be passed the movie ID itself. That's all it needs to know. So they can use that movie ID to construct the HTTP string in order to communicate with TMDB. So the question is, inside in this function, because I've got to implement this function, how do I get at this particular key value? And it turns out that the use query hook passes an argument. So I'm showing you down here an excerpt from the query function, as it's called. React query will pass an argument to my query function, where the argument is an object. That object has a number of key value pairs, but in particular, it has a key called query key. So this entire expression here is actually going to be, it's going to be a reference to this structure here. And so sensibly what I'm doing is I'm taking this expression and I'm applying destructuring to it. I'm destructing the array, and I'm particularly interested in this part here. So now this is going to declare a variable called ID, and ID will be equal to 1, 2, 3, 4, 5, 6. This is just standard array destructing, which I'm sure you've seen before. So all I'm saying down here now is I can do my HTTP GET request using whatever value has been bound to this variable. And let's go back to the code and see that. So here's the movie details page, and it's the same kind of process, really. You remove the state management code that we hard-coded ourselves, and you put in an invocation of the use query hook, which again is explained in the README. So I need to copy all of this. Now the movie details page is linked to a parameterized URL. So all I'm doing here is accessing the movie ID from the browser's address bar. We've seen that before, and I'm using the movie ID then in my query, as I illustrated on the slides. And here I'm constructing my key, and I'm passing the function that the React query will use should it need to communicate with the API. And I've got my kind of standard boilerplate code for dealing with when we are waiting for the data to come back and if there's an error. So other than that, in this function, you've really seen from the slides, but here it is here. I'm using the args because React Query will pass in this args object to me, and I'm accessing the movie ID from the key that I passed to use query hook. So now I've got a variable called ID, which will have my movie ID, and I'm using it in the HTTP string. So it's the usual same story as before. And now if we save those changes, which is this change here. Now there is one other piece of the jigsaw that I haven't shown you so far, but I'll come back to that in a moment. So I'm going to go back to the home page and start from scratch, do a manual refresh. And you just watch what's happening on the right here. So I've requested all the movies from the Discovery API, Discovery endpoint. I'll click on the first movie, which isn't in the cache, so I had to make the HTTP call, go back to the home page. There's no new HTTP call. Go to the movie details for the same movie. There's no new HTTP request. Back to the home page. Still no need for any other HTTP communication, but if I go to a different movie, then it realizes it doesn't have that movie in its cache, so it makes the call to TMDB. So that seems to be working. Now, the other one piece of the jigsaw that I didn't show you about React Query is that you've got to do a little bit of configuration of the React Query library, I suppose, and you tend to put that in your index.js. So you can see here what I'm doing is I'm creating an instance of what we call a query client. So it's just an object that you create and you configure it. In most cases, the configuration that I give you here will suffice, but essentially what we can do in the configuration is tell the React Query library how long it should wait before it deems an entry in the cache to be stale or out of date. That's what I'm doing here. By out of date, we mean that the next time my React client requests, so it has the data in the cache, but the next time my app requests that data from the cache, then it shouldn't use what it has in the cache at the moment because that data is stale, it's out of date. It should actually make a new request to the backend for the data. So what I'm saying here is that essentially after an hour, 1 hour, each item in the cache, if it has been there for an hour, it should be deemed stale and should not be returned to the React client, to the React app if it's requested by it. So it's just an arbitrary choice, but in our case, you know, most of the entries in the cache, they could survive an entire day. So whatever that equates to in milliseconds, that's what the purpose of that entry is. This one, refetch the data, is telling React Query how long it should wait before it should itself request the data, even though my React client doesn't need it. Again, this is just an arbitrary choice. I've said an hour, but it never really applies. The third option here is if you move away from the particular browser tab, in other words, if I go to a different tab and then I come back to my React app, do I want React Query to refetch certain data? It's up to me to decide that. I've decided no, it doesn't need to. And that's what the effect of this configuration setting is. So as I said, these are just configuration settings for your React Query client. And there are many more. Now, so you create an instance of this client and you then need to use it like this. Note here, provider. So React Query Library actually uses the provider pattern as part of its implementation. So you need to use this particular component. This is a component that's provided by the library. You can see I'm importing it there on top. And you need to pass to this provider component the instance of the client that I have just created up here. So that's kind of boilerplate configuration that you need to do. And so inside in our components, when we are using the use query hook, the use query hook is essentially using this query client to do the heavy lifting for it, you know, to manage the actual cache. Now, in the demonstration so far, I've been using the dev tools built into my Chrome browser to demonstrate what's going on behind the scenes. But in fact, the React Query library has its own dev tools implementation, which is really a very powerful addition to the tool and very useful. And it allows us to get a lens into the actual contents of the cache and indeed manipulate. It allows us to manipulate the cache as well. So in the screenshot here, you see what the dev tools that comes with the library looks like when you use it. And so what it's showing us, for example, is that on the left, it shows us the keys that are currently in the cache. And if you click on any one of these keys on the right, you'll see the data associated with that key. As well, what the As well, what you can do with the dev tools is you can actually manipulate the contents of the cache. And so on the screenshot I'm showing you, if you use these buttons here, they carry out certain actions on whatever entry you've currently clicked on. So again, the process is click on one of the keys and then trigger one of these actions. And you can tell from the caption on the buttons roughly what the actions carry out. If you click the refresh button, you're just forcing the React Query library to re-request the associated data. So you're actually controlling the cache from within this dev tools, which may be useful when you're debugging. So the refresh button forces a refetching of the data. The invalidate button will cause the associated data to be tagged as out of date or stale. And we know what the consequence of that is. The reset only applies if your React app is actually modifying the data that we've requested from the backend. That doesn't really apply to TMDB, but it is very often the case. And that is why really data might become stale. When I talk about data in your cache or a particular entry in your cache being stale after a certain period of time, it would only become stale if it's possible for another user using another browser to modify the data that's being stored at the back end. And really it's a question of then how frequently does that happen, and that's what dictates what you regard as the time to live value for entries in your cache. The time to live and the staleness are kind of relate to the same aspect of your cache entries. The remove button does what you think it does. It just removes the current entry that you've clicked from the cache. So it's a really nice addition to the tool, to the library itself. Now, how do you enable this dev tools that comes with the library? You do it at the code level. And if we go back to our index.js, it really comes in the form of a component. And here's the component here. And you just tag it on as I did down here in your main routing configuration. And so by including that component, what you see in your browser is this image down here at the bottom left. And if you click that image, that opens up the dev tools that comes with the library. I'll close off the dev tools of the browser itself. And so let's play around a little bit. Let's do a refresh, maybe go back to the home page. And if I do a complete refresh, manual refresh. So here we go. There is one entry just being put into the cache. The key is discovery. And if I click on that, then you can see, you can interrogate the data, the full list of movies, which would be in the results. These are our 20 movies. You can drill down into them. If I go to a particular, click on a movie, a new entry has been added to the cache. Go back to the home page, click on another movie, back to the home page, click on another movie, and you can see the cache being built up here. Click on a particular entry and carry out whatever operations you need to, or you on the entry, if any. There's also a kind of a color coding here that that the library uses. So green means that the item is not stale and it's currently being referenced by some component. And if I go back to the home page, for example, So because I'm currently looking at a particular movie and it's going to be this movie here, if I go back to the home page, now the current entry that I'm looking at, or the current entry from the cache that's being used by my React app, is the discovery entry. And because it's green, it means it's still, or it's not stale. It's still up-to-date data. If I tweaked the time to live, we would see that changing. So let's just do that. If I say the time to live is just, let's say 3 seconds. Let's make it 4 so we have a chance to. I did a full reload, obviously. So it's gotten discovery and it's gone back to yellow. So it's 4 seconds have elapsed. If I go to a movie details page, okay, there's a new entry. It's still not stale, but it's now gone to stale after 4 seconds. Go back to the home page. So because the discovery was tagged as stale, it's now going to re-request it again. So it's green again, and it has re-requested, and you could prove that by opening up the developer's tools. You would see a new request for the discovery list of movies, but that's only because I have deemed that after 4 seconds have elapsed, it's possible that the list of movies has been updated at the back end, which isn't the case, of course, but that's what the configuration of the cache, the stale time configuration entry, allows you to control. So the general area that we've been talking about is referred to as state management. State means data. So what data does a single page app need to manage? And there's 2 forms, as we said, client data and server data. Client data is straightforward enough, really, because it's local to each instance of your single page app. Server data is data that we acquire from the back end. Now, that means that could delay the page load time, waiting for the data to arrive. We have to get it initially, but what we want to try and ensure is that we don't re-request that data unnecessarily if we're pretty certain that it hasn't changed since we loaded it the first time into our browser. And a technology that helps deal with the issues related to server state and storing server state locally in the browser is to use a cache. So cache is essentially a key value store, and it's a browser local copy of some server-side data. And the benefits of a cache is that it eliminates unnecessary traffic across the network. The downside, though, is that the cache may contain stale data or data that isn't fresh. So you've got to be aware of that kind of balance between showing the user loading the page quickly, but the possibility that the user is looking at data that's out of date. The way we deal with the staleness is to configure our cache using a time to live configuration, so that once entries are in a cache for a certain period of time, then the cache will tag them as being out of date. And the next time the app requests that particular cache entry, the caching technology will immediately re-request the data because it's potentially out of date. What the React Query Library actually does is, when a page requires a particular entry from the cache and there is a cache entry there to match it, but it is stale, what React Query will do is it will first of all show the stale data to the user because it has that immediately, and so the page load will be immediate. But in parallel, it will make a HTTP request to get an update of that data. And once it receives the update, then it refreshes the page with the updated data. So you kind of get the best of both worlds. You don't have a kind of spinner on the page waiting for the data to load. You get something displayed immediately, and then it's refreshed once update data is available. So the library that or a library, and it's easily the most popular one to implement caching for React applications, is this React query library, and it simply provides a set of hooks. We've only seen one hook. There are many others, though. If we look at the online documentation, there are many other hooks that can be used for other different types of scenarios. Now, this is the last topic that I want to cover, and it relates back to the routing and navigation material that we've already covered. There's one sample in the set of samples that I gave you that we need to look at, and that sample has an implementation of what are referred to as protected or private routes. So it's a fairly standard feature of any single page app that certain pages within your app first require the user to authenticate before they can access them. Now, I suppose if we look at the sample in action, as I said, the feature set is fairly common to us if we've used any kind of online applications. So these are the samples from a few weeks ago, and it's sample 9 that we're looking at. So if I configure this to now go to sample 9. Start up my server. So here's my home page, Maria, and at the top I've indication that to the user that they're not currently logged in, and if they want to, they can just click on this button. The pages, let's say the different pages that a user can access are these. The home page and the public page don't require the user to authenticate, but if they want to try and access either of these, then they're forced to log in. So in other words, if we try and access this, I'm now redirected to the login page, and I've left out the username and password fields. We're not interested in that. When I click submit, behind the scenes, my application would validate the user's credentials, and assuming that they were okay, it would then redirect the user to the page that they wanted to access in the first place, which in my case, I think was the profile page. So if I click on submit, I'm now sent to the profile page. And I can now access, I'm now authenticated, so I can access the inbox page, which is also, in my case, a protected route. Eventually, I can sign out, and usually you redirect the user back to the home page when they sign out. Well, I'm actually redirected into the login page, which is okay. I suppose that's normal enough behavior. And I'm now can no longer access any of the protected routes. So we want to implement that kind of logic in a React way. So that page just explains the objective. Now, the third-party library that we're using, because React itself doesn't handle routing or navigation, we're using the React Router library, and it doesn't really have a solution for us. We've got to implement our own. Now, our objective is to implement our solution in a declarative way. So what I mean by that is, in our routing configuration, this is what we'd like our routing configuration to look like. So it's very clear what the intent is. It's saying that, well, this is an ordinary route, this is another ordinary route. Anybody can access these pages. But once you try and access this URL or this one, then they are private, and the user needs to authenticate first. So it's kind of declarative what I'm stating here in terms of the routing aspect to this app. Now, there is no component called private route we have to implement that ourselves, and we have an understanding as to what its purpose is and how it should operate. So in general terms, my solution is going to involve the following. I'm going to have a context, that stuff that we were talking about at the beginning. I'm going to have a context that is going to store the currently authenticated user, and it's also going to have the logic associated with authenticating somebody when they try to log in and signing somebody out when they request that. And number two there, I'm going to have a lot of programmatic navigation. For example, when the user tries to access one of the protected routes and they're not currently logged in, then we need to programmatically redirect them to the login page. Also, when no matter what page, assuming user is currently logged in, once they click the sign out button, then they are redirected back to the login page. So that again will have to be done using programmatic navigation. Number three here is a feature that we'd like to support as well. And it is this idea that, like, the simple way of implementing authentication is when the user tries to access a protected route, okay, they're redirected to the login page. And then when they fill in the username, password, and click submit, assuming that they are a valid user, we could just by default send them back to the home page. And then they can navigate to the particular protected pages that they try to access in the first place. That would be a simple solution. Just always send them back to the home page once they've authenticated properly. But it's nice if, from a user experience point of view, if we redirect them to the actual protected route that they were trying to access in the first place once they've authenticated. So that's what I'm saying here about trying to remember where the user, what the user's intent was when they were forced to log in. So I'm just going to step through some of the code excerpts. The full code, obviously, you can access by drilling into the sample line and looking at these individually. So in terms of the different aspects to our solution, I'm going to have a context provider specifically concerned with authentication. So I'm going to call it my auth context. And in terms of state, it's going to store the currently logged in user. Now I'm storing the person's username. I'm storing the person's password as well. That's probably not a great idea, but we can ignore that. But either way, this object here, the username part, will be null if there isn't a currently logged in user, and it'll be something other than that if the user is authenticated. Here's my function for carrying out authentication. Now I've left this out. I'm not interested in the detail as to how I authenticate the user or not, but once the username password combination is valid, then I change my state, which of course triggers a re-rendering. This is my function that's going to be executed when the user clicks the sign out button. The only reason I'm using set timeout here is just to simulate the idea that there would be a delay. Perhaps in a real life situation, my React app would communicate with some sort of backend, maybe sending it some analytics related to the user's usage of the application. So that's the only reason I'm using set timeout here. But critically, from a state management point of view, I am changing the state variable that I've declared up here on top. I'm resetting back the username to null and the password to null. This here in the middle is a convenience that I've declared for myself. So this variable here will be true if there is somebody currently logged in. It'll be false otherwise. And in terms of my context that I'm making available to the rest of the application, I'm making the two functions, and I'm making this variable also available to other components. So that's fairly standard stuff from a React context perspective. We can understand that code. Now, in terms of this private root component, we have to implement that. And we've seen that this private root component will be part of an application's routing configuration, but the behavior is what we have to implement. And in general, when one of these components is triggered, it essentially needs to check, is there a user currently authenticated or not? If they are, then we can redirect them to this particular path and mount the relevant component. If they're not, then we need to redirect them to the login page. So here's my implementation. And okay, I'm accessing the context. All I'm doing here is I am extracting the particular component from the private root entry. So this is going to declare a variable called component, and it'll be assigned whatever component name is used in the actual private root entry. Rest will be a variable that will have all of the other props. For example, it'll have this prop and any other default props. Here, I'm obviously checking, is there somebody currently logged in or not? And at a very high level, if they are logged in, then I'm returning a normal root component. So the way you can think about it is at runtime, when one of these private root components is triggered, and it would be triggered, for example, if the user tried to access this path, then if the user is logged in, this private root component will be replaced by a normal root component. That kind of happens dynamically. The specifics of the root component that will replace the private root, I'm configuring it here. So I'm essentially using the two variables, component with a capital C and rest. I'm using those to initialize the props for my ordinary root component. If this expression evaluates to false, means somebody isn't logged in, then my private root entry in the routing configuration is going to be replaced by a redirect to component. And specifically, I'm redirecting them to this URL. In other words, I'm causing the browser's URL to change to /login. And we saw from our routing configuration, if I go back, if the browser's URL is changed to that, then that's going to be matched by an ordinary root entry, and it's going to essentially load the login page, which we'll look at in a second. Now, when the login page is loaded, what I'd like to do is to pass on to that login page where the user was trying to access before we redirected them to the login page, which is this kind of remember feature. And that is what is going on. That is what's going on here. The effect of this part here is to pass some additional props to the login page. I've decided to call the prop from, and the prop will be initialized to props.location. Props.location is one of these default props that the React router initializes for us. So props.location now is being accessed from the props object up here. And I'm showing you here in the kind of screenshot what props.location, what that object kind of looks like for one specific example. So critically inside the props.location, it would have /inbox, and that's only for this particular use case here now. It would have /profile, in another scenario. So that's fine. So let's follow the redirect scenario. So the user has tried to access the inbox page. That caused the browser's URL to change to /inbox initially. That was matched by this entry in my routing configuration, which means this code now executes. There is nobody logged in, let's say, so this expression evaluates to false, or this entire expression is not true, which means this is active. And we know what the redirect to component does. It will change the browser's URL to, in this case, /login. And as well, as I've already explained, I'm passing some additional props to the login page. So I've redirected the browser to /login. The React app will reconsult its routing configuration, and it will discover that there is an ordinary root entry to satisfy that, and it'll eventually redirect. It'll mount the login page. Here's my login page implementation. And on first rendering, it's just going to display the login page onto the screen. Now, I say on first rendering because this expression here is going to evaluate to false, so it doesn't execute this at all, doesn't execute the redirect. So it's going to display my login page. The user fills out the login form and clicks the login button, which triggers this function up here. And I invoke the authenticate function in my context, passing the username and password that was entered by the user. I'm just hard coding some stuff here. The authenticate function does what you'd expect it to do, and let's assume that the username password combination is correct. It will change the state variable above in my auth context. That means the auth context provider component will re-render. And as a result, because this page is currently mounted onto the DOM, this page will also re-render. On this second re-rendering, as it executes through it, this expression is now true. And so my React application executes a redirect again, and it's redirecting to whatever this from variable is initialized to. Now, how does that get initialized? And the answer to that is up here. Just to explain this statement here, I'm not sure whether you've seen this kind of JavaScript statement. If I just go back to, if you've got a JavaScript statement of the following structure, I'm just going to write it in here. This is just a JavaScript issue now. So I'm declaring a variable called x. And the way it works is the JavaScript runtime will evaluate this expression. Let's call it expression 1. Expression 2. It evaluates expression 1, and if that evaluation is true in the JavaScript sense, so that would mean, for example, if the expression evaluated to an object or a primitive or an array, that would all constitute true, then it assigns that expression outcome to the variable x. If, on the other hand, this expression 1 evaluated to false, examples of when it would evaluate to false is if the expression evaluated to undefined. In that case, it evaluates expression 2 and the expression 2 evaluation gets assigned to x, irrespective of what expression 2 evaluates to. If expression 2 also evaluated to false or undefined, it doesn't matter. It'll still take what expression 2 evaluates to and assigns it to x. So it's a bit like, expression 2 is a default value that's assigned to x if expression 1 doesn't evaluate to something sensible. That's what's going on in this statement here. And of course, props.location.state, that actually is what I was initializing here. So the question is, when would props.location.state evaluate to false? Well, it would evaluate to false if the user landed on the login page as a result of clicking the login button at the top of the screen. Sorry, now if the user logged in by just clicking on this button here, they went directly to the login page themselves, then in that case, we really don't know where we should redirect the user to. And by default, we're going to just redirect them back to the home page. So the way I'm achieving that in my code is I am constructing a new from object here where I'm setting the path name to the slash, which will, again, that will cause the browser's URL to change to this, and then the matching route entry will load the home page. So that's quite tricky what's actually being achieved there. So this idea of remembering where the user tried to go to before they were forced to log in and redirecting them back to that page after a successful login, achieving that is quite complex. So either way, this from variable is either going to be equal to this expression here, which would mean that path name would be equal to something like this, or it's going to get its value from here, where path name is now going to be this. And when we then redirect them to from, the from object is going to have a path name of one or the other, and the redirector will change the browser's URL based on whatever the from.path name is equal to. Okay, so obviously I think you should play with the code and stick in console.logs in various places if you need to understand how these how the mechanics of this actually works. It is quite tricky actually on first viewing.